No? All right, so with that, we'll move to the next item in the agenda. So I'm really happy and thankful for this day where we get the chance to introduce Elena and Emeli from the Evidently.ai company and project. And yeah, I'm happy to welcome you. So I don't know if you would like to briefly introduce yourselves and share with us probably something you enjoy doing outside work before your presentation.
Let me maybe start. So my name is Elena. I'm CEO and co-founder of Evidently. And well, outside of work, I do enjoy working on other stuff. I guess that's how it happens when you're an open source co-founder, right? So there's some things that I enjoy doing, for example, writing blog posts or reading stuff. So that occupies quite a lot of even my free time. And hello to everyone from London today.
Yeah. Hi there, I'm Emeli. I'm co-founder and CTO at Evidently. And well, that's a really good question, what you like to do outside of work, because we're really very excited about Evidently, about building different things, metrics and tests. We're going to tell about it later. So maybe to add to it, in my free time, I like to walk a lot. So exploring London, that's a new city for me. And I like to play basketball.
Awesome. Thank you for sharing. Yeah, probably Ketan can relate to the amount of free time that a founder has. So, all right. So welcome. Yeah, let me stop sharing my screen. It's all yours.
Thank you for the introduction. Just to explain what we're going to do now, I will share my screen and walk you through the slides, but it will take you 2-3 minutes. I know that no one likes slides on these calls, and then we will see the actual code, so you will enjoy it probably a bit more. So here it is, just a really quick reminder. Hopefully you can see my screen now of what Evidently is and, well, what are we doing? So Evidently is an open source Python library. It is built for data scientists and machine learning engineers. To be fair, it's used quite a lot by data engineers as well, and probably titles don't matter that much. But the general premise is that we focus on machine learning models in production, and we help evaluate, test, and monitor whatever's happening with these models when they're actually being in use. So we are happy to say that we are probably the most popular library in this segment. So we have over 3 million downloads, 3,000 GitHub stars. And so overall, we have been building the tool now for approaching 3 years, focusing on building first a very valuable open source project. And like you all know, it actually takes quite a lot of time to cover all sorts of use cases and integrations that might be relevant. When we talk about machine learning model monitoring, it often question that comes up is basically how is it different from, well, traditional monitoring or service health monitoring, application performance monitoring, and so on. And the idea is that, of course, when you have a machine learning system in production, it is still probably either a service or a pipeline. So you need to actually monitor that, well, it operates, it works as expected. But there are additional layers of complexity which are related to the data that is flowing through these machine learning services and also to the health of the machine learning model itself. So for example, the model might be predicting something like maybe forecasting sales, but then you actually need to know if the forecast is good, or maybe there is a drift in model accuracy, or maybe there is a change in the incoming data, or maybe the model is becoming biased or is underperforming in a particular segment. So there's actually a lot of other stuff which is not related directly to the software performance. And this is the components that we focus on at Evidently. And Evidently has 3 different things, so 3 different, well, components of the tool that can be used together or individually, because we've seen that the solution of this task, how to monitor and observe and debug your machine learning systems in production, can be solved differently. So one component is called reports, and this is basically a beautiful visual report that you can generate directly in Jupyter Notebook or export as an HTML file, and it allows you to understand a particular aspect of your data or of your machine learning model. It can be used even for monitoring. For example, if you only do batch predictions once per month, you probably don't really need to set up anything more complex, so you can just generate this report, look at it, and see what you want to do with it. Then we have a component that is called test suites, which is probably most relevant for this talk. And this is best for, well, use in automated checks and automated pipelines. So for example, every time you receive a batch of data, or you generate a set of predictions, or maybe you receive the labeled data that comes later, you might run a test suite to understand that there is no change to the data, detect data quality issues, evaluate model quality, and do it in an automated fashion so that you don't have to actually look at the report if everything is fine. And lastly, we have a component that is called monitoring. So you can launch it on top of everything else. So for example, if you're running a lot of checks, or you actually have like a live system and you want to closely monitor what's going on, you can also deploy an Evidently service and have a user interface where you will see how all these metrics change in time. So all these three components are interconnected. So the monitoring UI actually sits on top of reports and on top of test suites, but you can also just use the test suites or reports if that's all you want. And we believe that's a very easy way to start because, well, you can start very quickly. And now Emeli will exactly show you how. There are a lot of checks. I will not go into details because I think it's best to see exactly with the example, but to just explain, Evidently covers data quality, data drift, model quality, and there are about 100 of different things that you can evaluate under these dimensions for text data, for tabular data, or for embeddings. So here's the end of my presentation. Now let's go to the code.
Great, so I'm going to share my screen now. Okay, just a second. Should be fine now. Cool. Now you can see that today is the day when I actually downloaded Zoom to my
New laptop.
Yeah, sorry for that. So now that's fine. And yeah, thank you. So hopefully it should be fine started from now. And I'm going to show you quickly how you could use Evidently for testing and validating your machine learning model pipelines and data-related pipelines. So basically, I want to start from the point that Evidently is a Python package. So in order to use Evidently, you need to install it, and it's available in PyPy. So you can just write pip install Evidently or conda install Evidently if you prefer to use conda, and you will get it. The only one thing is it's better to use a virtual environment to make sure that you do not damage any of the dependencies you have installed or other packages. So basically that's it. I already installed Evidently and I'm imported, and together with Evidently, I imported a couple of things related to different metrics and tests Evidently includes. So that's metrics for data drift and many tests, which we are going to see a little bit later. In order to have some data for demonstration purpose, I decided to use bicycle demand prediction dataset, which is very popular and unknown dataset, where we have a lot of data related to the season, to temperature, humidity, wind speed, and the task is to predict how many bicycles will be taken to a rent. The business idea behind this case is to try to optimize the usage of the bicycles, and maybe if you have some information about how many bicycles was taken to rent in different places, we could optimize the amount of bicycles we place in the different locations. So that's basically the idea. And in our case, that's a regression problem. So we predict how many bicycles will be taken to rent depending on the weather and the season. So this is the preview of the data we are going to use. And I have a date time as an index. Well, I also pre-trained regression model. So I have some helping variables like the name of my target function, the name of prediction, and we have some different type of features, some numerical like temperature, humidity, wind speed, hour, and some categorical features like seasons, holiday, and working day. Basically, for demonstration purpose, I split the data into two parts. So we have reference data, which are data from the beginning of January till the 28th of January. And we also have current data set, it's the next 4 weeks, and the idea is that we process data in a batch mode. So our reference batch, which we use to train the model, will be from January, and the current batch is like a next batch where we never train the model, but we are going to apply a model to this new part of data and see what is the quality of our data and model performance. So that's basically the idea. Now we simulate the batch usage of the model, and if you use some workflow manager to orchestrate your data-related pipelines, I hope you use Flyte a lot. So that's basically the example of the task you could implement with help of task of workflow manager. So I trained the model, which is random forest regressor. Then I generated my predictions for reference data and for current data. So basically now my data frame looks like this. So I have additional column, which is called prediction. And now we can see how Evidently can help you with the testing and validating your data-related pipelines. Before starting to generate test suites and reports, I want to create a column mapping, which is the helping object to make sure that Evidently parses data correctly. Basically, Evidently can parse the data automatically. In this case, you can just skip the step with generating column mapping. But in case you have some, let's say, non-trivial cases where, for example, initially you had categorical features and then you transformed it to numerical, for example, to be able to use those data in machine learning models. So in this case, Evidently will think that those data are numerical just because it takes into account column types from your Python's data frame. But if those features are meant to be categorical, it's better to say it to Evidently straightforwardly, so that Evidently will then choose the best algorithms, for example, best data-driven test detection methods to process your data correctly. So that's how you can do that. Syntax is very straightforward. It looks very similar to a standard Python dictionary, where you just assign the values of your parts of data frame to Evidently. So that's target, prediction, list of numerical and categorical features as well. And there are some more data. Well, now it's time to build first test suite. And for doing this, you just need to import test suite object from Evidently, here it is, and create our own test suite. I will start from preset. And preset is the well-combined number of tests, which helps you to tackle specific step from your machine learning pipeline. For example, here I'm going to use data quality test preset. I also imported it from the very beginning. And basically, to create your test suite, you just need to import this object and then specify tests. Here is the list. In our case, I just use my preset. So that's the number of tests, which helps to figure out what is data quality. And then we need to run our test suite. For doing this, we need to pass the reference data, current data, and the column mapping, and then basically we can explore the results. So Evidently can help you to set the conditions for your test automatically without passing specific conditions to each individual test. And in this case, you need to pass reference data. This is pretty handy if you have a lot of models and you don't really have a lot of resources to decide on conditions for each individual test. And that's a very nice starting point. So let us try to do that. So basically, I run the cell, and for now, I'm going to just show the results inside of Jupyter Notebook, because that's pretty handy for ad hoc analysis and understanding how it works. For doing that, I use method show, which shows me the output, and mod is inline. So I'm going to see the results right there. We have a summary with our tests. So data quality test preset in this case contains 26 different tests, and you can see that 22 tests were successful and 4 were failed. Basically, here we can group our tests, for example, aggregate by test status, and explore only interesting tests which are failed, right? So we can open up and see that basically those are tests related to the most common value of some features, right? Everywhere we have some additional information, and we can check what has happened, what was the most popular, most common values in current data set, what was the most common values in the reference data set, and see what's going on there. Together with preset, you can use individual tests. So basically for doing that, instead of preset, we need to specify which tests we are going to include in our test suite. So here in my tests list, I have individual tests. In this example, I decided to use test for column drift, for the column temperature, test for mean value of the column, that's numerical column, so I can do that, and test for quantile. Here I need to specify for which column I want to perform this test. I used temperature, and when it comes to quantile, I need to specify which quantile I want to calculate. For example, it can be median, right? So again, I have my reference data, so I do not have to pass any test conditions. In this case, I just run my cell and see that all my 3 tests are failed, right? And I can open up the details, for example, for drift per column, and I can see that, well, there is a specific shift in my distribution. So my reference data is shifted to the left, and my current data is shifted to the right compared to the reference data. So that's why drift is detected. And well, if, for example, I see that my tests are too sensitive or I want to pass different conditions, I can perfectly do it. In this case, I just add some conditions to my very same functions. So again, I use my test column value mean and test column quantile value, right? But now together with the column name, I specify specific conditions. Here, for example, I use 2 conditions, that's left and right, less than or greater than. So here I prefer to have my mean value for column temperature less than 0.3 and greater than 0.5, right? And very same logic for quantile, but only one condition here. And you can see that now I do not need to have any reference data anymore because I passed all conditions, and well, reference data is not needed to any calculations. So that's how you can operate if you do not have any reference. And well, luckily now I have all tests successed, right? And again, any details that you might want to see. For example, like here is my current value, right? That's the value for quantile equal to 0.5, and that's my condition. So I can see that my quantile is like righter than my condition. So basically that's why it passed the threshold, because I expected it to be greater than 0.2. So that's how it looks like. Well, that's very convenient to explore the results of such tests inside of Jupyter Notebook if you need to run some ad hoc analysis. But if you orchestrate your task, like you can do in Flyte, you might prefer to have some different formats. And I'm going to show you how you can transfer your output to some other format, which is more suitable to automated runs, maybe to logging your data, to write some logs to database, or maybe create some graph which includes conditional tasks, and with help of different output, different formats of output. For example, if you output your data not as the visual objects but as the Python objects, I mean, well, it's also Python objects, of course, but if, for example, you want to derive some specific value and then decide whether to run the dependent task based on it, for example, based on the test status, you might want to have it in a like text format or Python dictionary format. So basically, together with show method, we have quite a lot. For example, JSON. In this case, you can use this output, for example, to store your data and analyze it later. Also, we have pretty nice dictionary format. I don't know why I don't have it here, but that's pretty easy to just show it. So that's just as dict method. And that's how it looks like. So basically, in this case, you can specify each value you want by keys, right? For example, tests, mean value, status, and you can derive this value and act based on these results. As far as I understand, you can, if you use Flyte, you implement your task as the Python function, then use task decorator. And for example, if you want to output those information, you can just output Python dictionary, and this should be fine. Well, if you want to share your results and use it somewhere outside of your script or your workflow, you can also generate some assets. For example, we have methods like save HTML or save JSON. So let me run it. In this case, you need to specify the path where you want to save your results. And I can open up, I hope you can still see my screen because it should be like this. Yeah, cool. So you can see that I just saved this report, so I can open up it separately, and it will be available as the standalone HTML file. So all the formats and all the data are very same, right? So that might be pretty convenient. And well, sometimes you might want to perform some post-processing with your data, for example, create data, then save it, and later, maybe if you have some failed test, or maybe you performing some historical database analysis, you might want to load it back, for example, some data from the previous year or previous months, but it's not very handy to, for example, store a lot of HTML files because they are pretty heavy. So in this case, you might save the snapshot from Evidently, and you will be able to load it later and restore the whole object to do any post-processing with this object. For example, here you can see that I just saved the object snapshot JSON, so it should be here. Yeah, just created, and now I can load this data. So let me load it and restore, like regenerate test suite. And basically, well, after I load it, so this is something weird. So I'm just loaded from here, and I can basically show it, and it will be fully restored, which is quite convenient to store and perform some analysis later. Well, finally, I want to quickly show you reports, which is quite similar to test suites, but reports include some more information and more visual plots, which helps you to figure out what has happened with your data. For example, if you see some tests failed, you can generate report and explore more visuals in order to dig deeper and debug the data quality and model quality. Now we have a regression model, so I can start from regression preset to see what's the quality of my model. So yeah, here it is. And I can see that there are a lot of metrics like mean error, mean absolute percentage error. So I have values from current and reference data set, and I have many plots, which helps me to figure out what's going on there, like predicted values and actual values in time. So all plots are interactive, so I can zoom in, I can zoom out, for example, switch off something. Or yeah, probably you would rather switch on actual and see on predicted values, but still it's all interactive. If you want to share with someone just the specific visualization, you can load it, right, and download it as the picture, and then use it whenever you need. And well, they have a lot. They have the errors in time metrics. We have, well, error distribution, so you can see whether your model tends to underestimate or overestimate your target function, which might be quite important for specific cases, right? That's error normality and many other visualizations which you might be interested to look like. And I can't help myself but sharing with you my favorite preset. I don't know why I have favorite, but still, that's data drift preset, where we have information about drift of your features, target function, and prediction. So here is the summary, how we detect dataset drift. So basically, we check the share of drifted columns, and if it's higher than 50%, then we say the drift is detected. So in our case, we had 11 columns. 5 columns were drifted, and we have pretty nice table where we can open up each individual feature and explore what's going on there. For example, here is our target function, count number of bikes we can open up and see the values in time. So basically that's the current values. The green line is the mean value for the reference date. So mean number of bicycles which were taken to rent was slightly higher than 56. Okay, and that's how this value changes over time. And we also have a distribution, which can help us to figure out whether there are some shifts. We can explore tails of our distribution and see that it's slightly moving to the right. So the demand for bicycles increases, which is, I believe, a good sign for business. Well, same information available for other features, so we can open up and see what's going on. There are some shifts for wind speed as well, which might be useful to derive from the data. And basically that's how you can generate reports from Evidently. Reports are also available in different formats, which are JSON and Python dictionary, so that you can get it in different formats. And well, I hope this will be very convenient to integrate Evidently in your pipelines and see what's going on with each step of your pipeline, starting from loading data preprocessing, feature engineering, till model training and using your model for new batches of data. Well, basically, that's all I wanted to share with you. Yeah, if you have questions, I'm happy to comment.
Yeah, I have a good question. This is Martin. So this is very impressive. And I see here KSP value, Kolmogorov, Smirnov is what you use, I assume here, right? So on the text side, what do you use for the probability estimation on the text side? Also, I mean, what's the metric there that you use to detect drift?
Well, we have quite a lot of metrics to detect drift, and yes, the default method, which is chosen by Evidently, automatically depends on the size of your data and types of the data, right? But together with Kolmogorov, Smirnov, and that test, for example, we have quite a lot of other methods. For example, we can calculate the distance between between probabilistic distributions, for example, with help of Wasserstein drift detection method, or we also use Kullback-Leibniz divergence, so we can choose. And well, when it comes, for example, to text data, we also have some specific metrics, which is not statistical tests, but also helps to figure out what is the difference and if there is a difference between your two texts. For example, in this case, we use domain classification methods, where we build the binary classification model, which tries to distinguish between your reference data and the current data. And if it can, let's say, reliably distinguish current data from the reference, we detect the drift. And we also shows you the strongest features, which are, in our case, if you pass to Evidently raw text, the specific words, and if it's embeddings, in this case, we use, we cannot really give you some information on like what words or what sentences are responsible for drift, but still we just give the information about the share of components and the quality of the separation of reference and current data.
Okay, great, thanks.
Awesome, thank you.
I have a quick question.
Yeah.
First of all, great talk. Thank you for that. Yeah, I've been tracking your work for some time now. I'm curious if you've found that there's some data set shift that doesn't actually decrease model performance. Because in theory, our models should be generalizable, meaning that they can like kind of extrapolate outside of the data set distribution, ideally. And I imagine if you're catching all data set shift or drift, might lead to a lot of alerts that may not actually have a model, like a negative impact on the model predictions. Is that something you've seen or no?
Yeah, that's a great question. Thank you for bringing it up. Indeed, it is like this, especially if, for example, you train your model on top of like thousands of weak features. In this case, you might see the situation when you have a lot of others, but it doesn't really drastically change your model or cause the decrease in quality. And yeah, we saw that, and this is the reason why we do have quite a lot of different algorithms to detect drift, which has different sensitivity, and we also allow us to pass different thresholds. For example, if it comes to measure drift as the distance between the probabilistic distributions, you can, for example, by default, we have 10% size of 10% condition to detect drift, like if the distance between the distributions normalized by the standard year error is higher than 10%, then we detect drift. But you can, for example, specify to 30% or 50%, and it will drastically decrease the number of false alerts. And yeah, by the way, I strongly believe that this is something that one should do. So customized like all the conditions in order to avoid false alerts. And also, if there are really, really a lot of features, and you don't want to have a lot of alerts, I would rather use metric like share of drifted features, and maybe if you have 2 or 3 very important features, individual drifts for those features, so that you can like decrease the amount of alerts.
Awesome. Thank you.
I had one question, just to follow up to what Neil said. I often see folks talk a lot about data drift, but to actually verify whether that alert is even false positive, you need ground truth. And in some cases, ground truths are very, very, very delayed. So now, what should be like, and I think this is for the community to help them understand, like, how do they handle areas like, in some cases, even we work with companies that do fraud detection, where ground truth doesn't, like the counterfactual doesn't even exist, right? Like, so you don't know. We work with companies, let's say a ride share company, and the final ride time is 3 months. Or you take an AV company, which are like probably, using some data, which the ground truth is on the next run on the same place, right? So there are like these different types of things, and hence, to Niels's point, it can become very noisy, and you really are not capturing enough information in that thing. What that ends up doing is people stop looking at the data, which is not the right thing, right? So there's a happy medium. And what do you recommend? How should you go about thinking about this problem?
Well, that's complicated, I would say. So if I take a small step back, I would say that if you have some delays with getting your target function, you need to come up with some solution in order to set up something like early monitoring. So before you like got your labeled data, you can see what's going on here. And I believe that in order to make sure we monitor for everything, we can measure not only data drift, but as well outlier detection. And for outlier detection, I fully agree that we need to have some labeled data. And maybe if we have some pretty strongly detected outliers, we might send them to manual review, for example, and see what's going on, maybe to speed up the moment when we get the labels, right? But when it comes to drift detection, basically what we do, we not pay attention to the individual objects, right? But we rather compare the distributions. And in this case, we don't really need this label. Of course, if you are not talking about the target drift, right, where we exactly need those labels. But if we have some strong features, and as soon as we get our model's output, we already can measure the drift between, for example, the model's output from the previous batch, where we were happy with the model's quality, with the current batch. And if we see that the output has shifted, and for example, there are like no obvious reasons for doing that, I believe it's pretty strong signal that something is going on. And well, I would personally never like create an alert for the drift for each individual feature. I would rather measure for the share of drifted features. But again, if you have like key features which influences the output of your model strongly, then it would be nice to have some individual drifts. So maybe a combination of the outlier detection, drift for important features, and share of drifted features might be the good setup. And yes, for all the rest features, I would rather measure something like data quality to make sure that there are no like a lot of empty values or corrupted values or whatever. And I think this theoretically should be enough.
Thank you. Yeah, I agree. One of the important things is, as you actually pointed out, the correlation is unknown unless you study the causality, right? Like you have to study it across different things, and people sometimes just create like, oh yeah, maybe this data change caused the problem, but that may not be the case, right? It might be something else. So thank you.
Just maybe to add a quick comment, is that probably you should not look at drift as some near real-term alert, right? So it's more like a regular analytical process, which tells to a data scientist like something is happening. You might want to look with your own eyes and decide what to do.
Which is actually a very, very interesting point, because there are a lot of people who are trying to do real-time data drift and so on. And this is a great point so thank you.
Awesome. Thank you all. Any other question? No. Right. With that, thanks so much again, Elena and Emily, for joining, for sharing your knowledge here. That was great. And with that, we are at the end of the agenda. So thanks everyone for joining, and hope to see you in the next one.
Thank you for inviting
Thank you,
us.
everyone.
Thank you.
Bye-bye.
Thank you. Bye. Bye.